This is Algebra 2 at Trig 2A.1b, talking about polynomial and their end behavior. When we discuss end behavior, which we have actually done in the past, end behavior of a function's graph is the direction the graph goes when x increases or decreases. So the end behavior, as you've learned it before, that's where we're looking to see which direction the graph is going as x gets bigger and x gets smaller. So we're going to come down here and we're going to talk about an odd degree to the first power. That would be linear. So the degree, you're not so worried about the number, but more concerned about is it even or odd. Because there's a pattern that's going to happen with evens and odds. So this is an odd degree. That means it's linear. This has a positive leading coefficient. And what I'm noticing is when x gets bigger, the graph's getting bigger. So as x increases, approaches positive infinity, the graph itself is getting bigger. And when we go to the left, when x gets smaller, we notice that the graph is getting smaller. It's going to negative infinity. So what I want you to notice is that when you have an odd degree, the graph will be going in opposite directions. We can look at that on a graph. We can look at y equals x, and we can graph that. And we see it increases to the right, it decreases to the left. We can try a more creative odd degree, which could be a cubic. And if you notice, it's also going to increase to the right and it decreases to the left. If you get a fancier equation in there for the cubic, there's our linear, and there's our other cubic. You'll see that it dances through here a little bit more. And even if we change that last zero, there's our linear. And you see that there could be a lot of movement, but in the end, it's going up to the right and it's going down to the left. Doesn't matter what happens in the middle. Doesn't matter how complicated the graph looks. An odd degree is going to go up to the right and down to the left as long as it has a leading coefficient. We could also have an odd degree that has a negative leading coefficient. So this one was linear. We could do a cubic. Doesn't matter what happens in the middle. The question is what's happening off to the ends. When x gets bigger, that's the direction you want to look first. Notice that a negative is going to be falling to the right. And then as you go left, as you look smaller x's, your y value is going to go in the opposite direction. Any questions about that? So if we're not odd, we could be an even degree. We know that an even degree would be like x squared. That's an even degree. That makes the parabola. We've done those before. We've done n behavior with parabolas before. If it's a positive leading coefficient, you know that the parabola is going to open upwards. When you look to the right, the graph goes up. When you look to the left, the graph also goes up. That's a pattern that's true about all even degrees. Even if we came in here, if we came in here and said x to the 4th power, look how similar that looks. And if we zoom in a little bit, move in a lot closer, you have your parabola and then you have your 4th degree. It almost looks like that 4th degree is going flat across horizontally, but it's not. It's just the pixels can't show more decreasing all the way to 0. It does not increase as quickly for a while until it gets up to this point. This is 1. Okay? If we get creative, we can change the graph. We'll get rid of that one. We're more interested in what this new polynomial one's going to be like. So x plus 3, x plus 1, x minus 1, x minus 2. You see it's going to go through the graph multiple times. All through those same zeros. Has all the same rules we typically would have. Looks like it drops down just below our window. We could change our window to be able to pick that up. I think 15 will be enough. And we could see the whole graph through there. So we start to get into some really creative graphs. We call these polynomials. So an even degree, if it goes with a negative leading coefficient, what do we think is going to happen? If we put a negative in here, the graph is going to open downwards. It still goes through all the same zeros. We'll talk more about that in the future. But even a complicated looking one, it may or may not hit the x-axis that many times. Right? We could change this. We could make it touch the x-axis less times. It was touching 4 times. Now we can make it touch 3 times. All by changing the equation a little bit. But it's still a 4th degree. Has a leading coefficient that's negative, so it's still pointing downwards. So as x gets bigger because it's negative, it's going down. And as x gets smaller, going to the left, because it's even, it is going in the downwards direction also. Notice that even goes in the same direction and odd goes in opposite directions. How's that going to look for equations? What do you need to know? Pause the video and work on questions A and B. All right, let's take a look at these. what I notice that the leading coefficient is negative. So that by itself is going to tell me, as x approaches negative infinity, my function is going to approach something. And as x approaches positive infinity, my function approaches something. Because it's a negative leading coefficient, I know my graph should be going down. That's the prediction by looking at the graph. Which way it'll be going. Because it's a negative leading coefficient, I don't even have to know about the degree yet. It's just a negative leading coefficient. That means to the right it's going down. Then I notice that it's an even degree. That means it's going to be going in the same direction. All these other numbers are just determining how much movement there is in the rest of the graph. Does it cross it 4 times? Does it just touch it once like a parabola? Okay, over here we see a leading coefficient that is positive. So if I think about my end behavior, I really don't know which way it's going to be going left, but I do know which way it is going to the right. As x gets positive, my g of x is positive, is going to be going upwards. And I know that strictly because it has a positive leading coefficient. Then if I look at my odd degree, get my DE in there, huh? Odd degree is going to be going in opposite directions. Seem good? What pattern do we see with seconds and fourth degrees? We're very familiar with second degrees. Fourth degrees following the same pattern. The end behavior goes in the same direction. We don't know if they both go up or they both go down until we find out about the leading coefficient. But the even degree is going to tell us they both go in the same direction. So we flip over. You see a chart of different graphs here. Notice what we have. It's called 0 degree if it's a constant. Flat, like the floor. You have a linear, which is the first degree, like y equals mx plus b, x to the first power. Here we would have a quadratic, x to the second power. We know that there's some more movement to it. Looks like it has a translation down. Cubic. Cubic's going to have 2 turning points. See that? There's a discussion we'll have later. It can cross up to 3 times, where a quadratic only has 1 turning point. It can cross up to 2 times. We all know that. It can cross twice, it can cross once, or it could cross none. Fourth degree, we call that quartic. It can cross up to 4 times. I showed you a graph that crosses 3 times. It's going to have 3 turning points. And then quintic, 5th degree, could cross up to 5 times, but doesn't have to be 5 times. Could be less. Going to have 4 turning points. So if we come down to our graphs here, what is our prediction? What is the degree? What is the leading coefficient? So pause the video, work through those 3 questions, give it a try. So our degree, we know that this is going in opposite directions. So I know that this is an odd degree. And I know that the leading coefficient is positive because it's going in the positive direction to the right. Here we have even degree because the graph is going in the same direction. And the leading coefficient is going to be negative because it's falling to the right. We only look to the right. That's all you need to do. And then here we're going in opposite directions. So you know that that's an odd degree with a negative leading coefficient. Because it's falling to the right.